Now we want to compute expectation from conditional expectation. So we noted before that this conditional expectation is a random variable. So thus we can compute its expectation. And if you compute the expectation of this random variable, it just comes out to be expectation of x. So this can be shown. So for the discrete case, this basically means you take the random variable and then you multiply it with probability that the random variable y will take on value small y. So again, recall that expectation of g of x, this is given as integration from minus infinity to infinity g of x, and then you have so here g of x is the random variable. So instead of g of x, you have this random variable. And instead of f of x, here you have f of y. And that is precisely what the expectation of conditional expectation is. So conditional expectation would be some random variable, and then you integrate with respect to the density function of y and then take dy. So for example, in the previous example, we had computed this to be some function, say small y, and then it's a function of y. So this is a function of, this will be a function of this small y, and therefore you can integrate over y, and what you will get is just a number, because now everything is in terms of y. So when you integrate it, you just get a number. So expectation of x is just a number. So let us see an example which will make things more clear. So say there is a miner which is trapped in a mine, and the mine does not have any light. So a miner without light is trapped in a dark mine, and the mine has two doors. So only the first door can lead him to safety. So if he enters the first door, he can go out in 2 hours. The second door leads to another tunnel which comes back to the same spot after 3 hours of walking. So he walks back to the tunnel. So what you can think of is that there is a room like this, and this room has 2 tunnels. So one tunnel takes him to safety in 2 hours, and the second tunnel leads him back to the same room in 3 hours. And once he's back in the same room, it is so dark he cannot tell which tunnel he took, because his orientation is completely lost. So he does not know whether he took the left tunnel or the right tunnel. So once at the same spot, the miner cannot tell which tunnel he took before. So we want to compute the expected time for the miner to come out. So note that if the miner is stuck in this tunnel, he could possibly go round and round in this tunnel, because every time he reaches the room he forgets, or he doesn't know which tunnel he took before. So he can go round and round and never get out, because this tunnel is totally dark, this room is totally dark, he cannot tell where he is. So we are trying to compute the expected time in which the miner will possibly come out. So expectation of x is, we are using this formula. So you are going to sum up over all the values. So this y is he takes door 1. So he can only take either door 1 or door 2. So this is door 1, y equals to 1 is door 1, and this is door 2. So we are using this formula here. So expectation of random variable x given y takes on value 1 times probability that y is 1, that's probability that door is 1, plus expectation of the random variable x given that y is 2, that is the door he takes is 2. So this is door 2. So he could choose either of these doors randomly. So probability of choosing door 1 is half, probability of choosing door 2 is also half. So you take half as common outside, you get expectation of x given the miner chooses door 1 plus expectation of random variable x given that the miner chooses door 2. Now if he chooses door 1, he comes out in 2 hours, so you have 2. If he chooses door 2, then he spends 3 hours inside and then he comes back to the same spot. So 3 hours inside plus, now again we have to start from the scratch. So again you have to compute the expected time of him to come out, because once he is here you're back to square one. He could choose either of these doors. So you solve this equation, so you get 2 expectation of x is equal to 5 times expectation of x. So expectation of x comes out to be 5 hours. And this is also intuitively clear. So suppose the person makes a mistake the first time, he goes in 3 hours here. So since he is choosing door at random, so since he has chosen this door first time, we expect him to choose the second door the second time. So he will take 2 hours to come out. So 3 hours in this tunnel lost plus 2 hours to come out. So total is 5 hours. But notice that it is possible that miner could continuously travel the wrong tunnel forever.